microphone.
Greetings and welcome, friends. Mr. Waddy here. Good to be here, folks. We are talking today about medians and altitudes. Wow, great special segments of triangles, which happen to create concurrency at a single point. It's amazing. It's amazing. So it says the point P is the centroid of triangle LMN, find PN and QP. So it says if Q to N, so that's this entire length, is 9, they're asking us what are P to N and what is P to Q. So we talked about the fact that point P will be 2/3 of the way along the, let's see, this was a median, right? Man, my mind went blank for a second there. Yeah, there's a lot of vocabulary in this section. Make sure we take the time to remember it. So the centroid is composed of the medians. What are medians, by the way? Could someone tell us? They connect a vertex to what?
The midpoint.
The midpoint of the opposite side, yeah. So 2/3 of 9, 9 divided by 3 is 3 times 2 is 6. So, that's, I'll call it NP there. So NP is equal to 6, and the other length by segment addition postulate and then subtraction property of equality would be 3. So, not bad, right? All right, let's take a look at this one here. It says point D is the centroid of triangle ABC. So here they said if DE is 9, they want us to find CD and CE. What are your guys' thoughts on that? How could I do that? Well, if this is 1/3 of the median and the other one is 2/3 of the median, CD is just going to be twice as long. So that's 18. And then CE is going to be the sum of those. So that's going to be, which is 27. Okay. Let's see. Here we go. Man, I chose a lot of centroid problems here. Well, I guess the Orthocenter didn't really have that much interesting that happened with it.
No, the Orthocenter is hard.
Yeah, it's like just all the altitudes make the Orthocenter, but it doesn't have any like cool qualities about it other than the fact that it is a point of concurrency between the 3 altitudes.
The altitude.
All right, well, we'll take a look at them. Point G is the centroid of triangle ABC. Gentlemen, if BG is 6 as labeled, and AF is 12 as labeled, and AE, where's the AE? Is 15, then it says find the length of the segment. So if I want to find FC, well, if BF is a median, because this was a centroid, then these are congruent, and by def of Kong, FC is going to equal 12. Agreed?
Yes.
All right, and BF, let's see, if this is 6, and that is 2/3 of the entire length, all right, I could find the entire length by multiplying by 3/2. It's going to be 9. This is going to be 3. You could also view this 1/3 as being half of a 2/3. All right, whichever way you think about it, that's going to equal 3. Oh, let me actually write that. Like so, BF is going to be the 3. All right, let's see. Sorry. What did they ask us?
Yeah.
Oh, they asked us for the, oh, they did. Oh, so thank you. Good save. Good save. All right, Haley with the save. Thank you. Thank you. Wow. Faithful are the wounds of a friend. I'd rather have a friend tell me the truth when it's hard. As deceitful are the kisses of an enemy. You know what I'm saying, Josh? You know what I'm saying. So, all right, check this out. This, all of these points are in the first quadrant. So hopefully my Orthocenter is going to be in the first quadrant too. So let's plot some points. L is at 0, 5. There's my L. M is at 3, 1, over 3, up 1. There's M. and over at 8, 1 is n. So over 4, another 4. Did I count that right? That doesn't feel right. 1, 2, 3, 4, 5, 6, 7, 8. There we go. Right there. Beautiful. All right, so let's we can at least draw the triangle, right? You guys got that far, I hope. Plotting points. Plotting points. Yeah, I tried not to have you guys get overkilled with some of these problems. All right, so here's my triangle. If I'm trying to find the orthocenter, well, it's going to be the intersection of the altitudes. The altitudes are kind of like the heights. It will be really easy to find the height of any side that happens to be horizontal or vertical. So I think we definitely want to find the altitude that connects to MN, and that is going to be this right here. Let's see, right there. Right, you guys agree that's going to be one of our altitudes? It's perpendicular to MN. Let's see, what is the equation for that blue line? It's a vertical line, so it's x equals a number. And it's x equals 0. It happens to be equivalent to the y-axis. Now, before I go any further, let's actually answer this. Where do you think it's going to be, inside, on, or outside the triangle? I think it's going to be outside the triangle as well. Yeah. So I think the next one that I want to work with is, I'm going to choose the one, what do you guys think? Passes through M, perpendicular to LN. You guys think that's a good choice? The other one's easier? Oh, the line was good. Yeah, this one. Yeah, I think this one's the easier one to work with. Something like that. So if I want that line, we'll call it the altitude of M. If I want that, it's going to have a slope that compares to the slope of LM. How so?
Perpendicular.
It's perpendicular, so what is the slope going to be? Opposite reciprocal. So the altitude of M will have a slope that is the opposite reciprocal of LM. So N, my bad. I was probably mumbling it well enough that you guys couldn't tell what I was saying anyway. So what is the slope of LN? It looks like it's just going down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. I could read that off the graph. I could also have read it off the graph by going from L down 4 all the way over 8, and negative 4 over 8 also becomes down 1 over 2. I also could have used the slope formula, which is y2, which is this right here, minus y1, which is this one right here, over x2 minus x1, right? So I'm going to get negative 4 over 8. I'm getting negative 1/2 either way for the slope of Ln. So what is the slope of my altitude? Positive 2. Okay? You guys buying that? You flip it and you change the sign. Now, my altitude is also going to pass through, all right, this point M. You guys agree? Now, I technically, because this is a slope of 2, I technically could start at M and just go up 2 over 1, up 2 over 1, and draw a line. I also can use the fact that a slope of 2 is the same as a slope of negative 2 over negative 1. And watch this, I could go down 2, backwards 1, down 2, backwards 1, down 2. That last down 2 didn't seem quite right. Sadly, I didn't draw this to scale. And I could draw the line that way. All right, and what I'm going to be looking for is the intersection between my vertical blue line, which happens to be the y-axis, and this line right here, this altitude right here. And that is going to be the orthocenter. All right, I'm going to do this for you algebraically real quick, as fast as I can. All right? So, here we go. To find the equation of this green line, I need to use the fact that it has a slope of 2 and it passes through m, right? M being 3, 1. So I'm going to plug that in for y equals mx plus b. I'll plug in 1 for y. I'll plug in 2 for m. I'll plug in 3 for x. And I'll solve for b. So plug in what I know, solve for what I don't. We've done this before. Subtract 6 from both sides, I get b equals -5. So between this slope and that y-intercept, the equation of the green line is y equals 2x minus 5. I technically already know my answer is going to be -5 now. But if I didn't, I could then solve the system of y equals 2x minus 5 and x equals 0. I could solve this system by substitution. Plug 0 in right there. I'll get y equals 2 times 0 is 0 minus 5, y equals -5. And so my orthocenter is going to be x equals 0, y equals -5, or the point 0, -5, which is outside of the triangle. There we go. Yeah, those problems take a little bit of time. Let's cruise on down to the last couple problems I wanted to look at. All right, complete the statement with always, sometimes, or never. So when I'm thinking about this, I want to think about different cases and then also maybe counterexamples or situations that when these apply. Let's see. The orthocenter is blank outside the triangle. What do you think? Always, sometimes, never. We're going to say sometimes. What type of triangle, Isaiah, would it be when it is outside the triangle? Right? Outside was obtuse. Right? Inside was acute, and it's on the triangle when it's a right triangle. Now, how about question 34? What is an altitude? That's the height. When or is it possible for an altitude to be the same line segment as an angle bisector? Is that even possible? All right, I'm thinking in the case of an isosceles triangle, we could have an altitude like that, and it's going to bisect that angle. Thanks for watching, Internet friends.